Hey, how's it going, everybody? I want to talk through another mock system design interview scenario dealing with a publishing service, a consuming service, and a queue. And my assumption with this queue is that we're going to be using RabbitMQ as the message broker. Um, so one common thing that you're going to encounter if you've done a system design interview is just your ability to explain how data moves through a system and what happens in the event of an error. So what's going to happen in this scenario here is I have a hypothetical engine service that is doing something with an engine processing data, doing something. It's going to publish that data out to this engine queue. So that data might have information about RPM, temperature, engine size, things like that. So that data will get to the engine queue, um, and then that message is then going to be consumed off of that queue by a logging service. And the logging service, hypothetically, is going to be responsible for consuming that data and then sending it to some logging tool like Kibana or Datadog or something like that. Again, this is just purely hypothetical, but it's just a example scenario. And what we're going to have happen is we're going to have this logging service, we're going to have this throw an error when it's consuming that message. So I'm going to make that in red. So the logging service is going to throw an error when it's consumed a message off of the queue. And we're going to go ahead and draw another box to say that what should happen is that that data that comes off the engine queue should make its way up to here. And this is just going to be we're just going to call it a database, something like that. It's going to be it's just sending it somewhere. It doesn't matter for this example. All that matters is what's happening in this block of the architecture. So what's going to happen here is this logging service is going to consume a message off the queue, and then it's going to throw an error. So we have to ask ourselves, if it throws an error, what happens to the message that is consumed off of the engine queue? Does it get lost? Does it get, what happens to it? Does it get logged? Do we just write the exception to one of our alerting tools? What happens? Do we need to reprocess the message? So we need to be able to explain, what we would need to do to set up that retry capability. So what we can draw out here to kind of articulate some form of retry, we can go ahead and draw just a little arrow back here. And then we're just going to add some text to say retry times 3. And again, this is just purely hypothetical. But what we're trying to articulate here is that we're going to try to retry consuming that message 3 times off the queue. If one time it fails, basically what happens in the queue is that we are going to essentially fail to send the acknowledgement back to the exchange, therefore indicating that that message was never fully processed, essentially. So it's going to actually remain on that queue, and then based on the built-in retry logic, we're going to then consume it again up to 3 times. And then what's going to happen is when we have exceeded that 3-time threshold, we're going to actually then send it to an error queue. So we're going to call that engine error queue. The error queue is then going to house any message that has exceeded that retry limit. So we're going to draw an arrow there, and we're going to say message retry, retry count has been greater than 3. So now we have an error queue that has our messages that have been failed to be processed. And what has to happen is really up to us. we can basically say that we want our engine service to maybe consume off of that queue and then maybe reprocess at the engine service level and then publish it back to the engine's queue for either another attempt, or we have to add in logic into the engine service to perform some kind of maybe some kind of revalidation on the data from that error queue as to why it ended up there in the first place. So this is kind of up to us at this point. But now we've kind of designed a way where we don't just, consume a message and then, just fire and forget about it. Basically, this is the terminology. We're keeping track of the state of what's happening with our messages. So now we can have a little more confidence to say that when a message is consumed off the queue, it gets to our logging service. We have the confidence to know that it's going to retry processing that message or sending it to a database, whatever it's doing. We're going to do that 3 times. If it fails those 3 times, then we're going to send it up to the error queue. That's then going to be consumed again by some service that's acting as the orchestrator for this whole thing. And it really depends on how you have it set up. If you have it set up in a choreography pattern, if you have it set up in an orchestration pattern, it's up to you. But this is a simple kind of approach to how that would happen with a retry policy. There's a couple things that we can consider on a retry policy. So I'm just gonna go ahead and add kind of a text box down here just to articulate this. So our retry policy can be linear in intervals. So I'll say it can be done in just linear intervals of we're going to try every once every 5 seconds. So after the first retry, we're going to wait 5 seconds, try again after 5 seconds, and then repeat times 3. We can have it as exponential. Exponential will try in 2 seconds, then 4 seconds, then 8 seconds, and so on and so forth until we hit that retry count. So there's a couple different things you can bring up when you're talking about retry policies. And exponential or exponential backoff, as you might hear it talked about like that, is beneficial when you're worried about either network latency, if you're afraid that an API may be down and you don't know how long it might take to be brought back up. A linear interval might not be the correct option for you. You might want to consider something that is more exponential in nature, just due to the fact that if you're aware that your API spin up time is like, maybe over 30 seconds, you might want to try exponential because sometimes that it takes 30 seconds, but sometimes it might just take faster. So you want to allow for that, kind of maybe time discrepancy, especially if you allow more than, 3 times retry. So there's just a couple of considerations you have to make there. Another consideration that we're going to talk about is our actual error queue and how that is handled. So on this model here, we have a direct consumer off of the error queue, but that might not always be the case, and we might need to set some form of time to live on those messages so they don't just hang out there in the error queue. So we're going to set a time to live value on those messages, and we can maybe set it to 1 day. So after 1 day, those messages will be purged from that queue. And another thing that we might want to track is, is the actual retry count itself. So this is the retry count on here would be a message header, but it'll signify to the consuming service that this message has been tried, X number of times. That way, it's good to have that set up because the engine service is not going to or shouldn't have any knowledge of the retry policy on the logging service, but the engine service might benefit from knowing how many times that message was tried to be sent successfully. just in case that the engine service wants to make any determination or logging off of that, especially if your retry policy is dynamic or is based on specific message types. So those are just a couple things that we can bring up when we're talking about a retry policy. Another thing, let me move this here. Another thing we might want to bring up when we're talking about how we're sending data through our system is we might want to talk about a specific message broker and technology that we're planning on using. That way it kind of brings, this hypothetical example or theoretical example kind of down into actual, practicality, into practice here. So I have my assumption that we're going to be using RabbitMQ as a message broker. RabbitMQ is based on, let me paste this down here. And again, these are kind of just scratch notes, but as you're kind of doing a system design interview, it's generally just kind of a lot of scratch notes like this. So RabbitMQ is based on this protocol, the advanced message queuing protocol. And there's a couple things that you get out of the box kind of with that. So you get general acknowledgments. And the way this works is that when you publish a message to RabbitMQ, what happens is that you actually publish the message to an exchange. So your message goes to the exchange and is then routed to a queue. Okay, so when your message gets to the queue and then is consumed off the queue, there's a whole host of message headers and a whole message frame that comes along with that message off of the queue. And this protocol relies basically on acknowledgments. So that's how retries work, because basically we're failing to send that OK acknowledgement back to RabbitMQ, signifying something went wrong with this message consumed. And I believe, I could be wrong about this, but I believe that RabbitMQ uses RPC kind of under the hood, remote procedure. RPC, is it remote procedure call? I could be wrong about that, but again, this is scratch notes. So basically, what happens is when you register a consumer to listen to your queue, at least in .NET, what you're basically doing is you're saying, okay, when a message is routed to that queue, we're going to go ahead and tell that protocol to execute a method on our registered service. And so because of that connection with that protocol, if there's no acknowledgement sent back to signify a successful completion of that method, then we know something went wrong. And that's how the retry policy is really built into this protocol. And one technology that we can use to connect to that is mass transit. Mass transit is just a communication library that's popular in .NET. It's not specific to RabbitMQ, but RabbitMQ is built, can be used with mass transit. And one thing you get is a retry policy that we can set. You can just define a number, and basically it'll set all this retry logic up for you. And it'll also automatically create the error queue, and you don't have to do anything. So if the retry count is exceeded, and the retry count is literally just a message, is just a property on that message frame. So when that has exceeded the count that you've provided to that policy, an error queue will automatically be made, and the message will send up to the error queue. So it's very, very nice, and it's very powerful, and it's just because it exploits what AMQP gives you. And that's a whole topic that you could kind of dovetail into on these conversations. But as a whole, as far as the system design, this model of retry counts, error queues, allows you to be a little more confident that your data is not just going to disappear. It's going to go somewhere, and service is going to have the responsibility of successfully handling that data. there's a lot more that you could add here, but this is kind of the bulk, at least, of starting to add a better guarantee of message processing. Again, because if we had just left it as the engine service, the engine queue, and a logging service, and then send it up to a database, if that logging service went down and we didn't specify any kind of retry policy on RabbitMQ, and we didn't have any of that set up correctly, that message has a potential to get lost, depending on how we have it set up. And if it gets lost and never gets to the database, consuming a message off of a queue is a destructive action. So it's not going to get back to the queue if we don't have that policy set up. And again, there's a lot more you can go into this. I tried to make it not .NET specific that much, but mass transit obviously is .NET specific. But yeah, so this is just one way of potentially doing this. And if you've ever had to talk through a scenario like this, let me know your thoughts. I'm going to go into actual code for this soon, but this is just going to be the rough overview